If we're given two functions, f of x and g of x, we can add, subtract, multiply, and divide them. So maybe just to pick a couple of these things, like we've seen one function added to another. Or maybe if you were dividing them, you could say like f of x, we'd use maybe this symbol divided by g of x. So these are ways to take two functions and combine them together. But there's yet another way to do this as well that we have not defined, and this is called a composition. So f of x composed with g of x means you take the function g of x, you're not adding, subtracting, multiplying, or dividing, but you're substituting it in place of the x here. So this is the notation that we'll use for f composed with g. You take the function f and you put g of x in place of all of its x's. So you can think of this as a brand new operation. Often this little circle is used to denote a composition, and you'd write something like f with the little circle, g, and we'd read this as f composed with g. And by definition, it means you take your function f of x, and in place of x, you put g of x. What I'd like to do for this lesson is just see what this means in terms of evaluating a composition. That is, if I give you two specific functions, what does it mean to plug a number like 6 or -1 into that composition? So let's figure this out. In example 1, we have f of x is equal to x squared minus 3x plus 1, and g of x is equal to x minus 5. Let's first evaluate f composed with g of 6. So the way this is going to work is, we're choosing x is equal to 6. We're then going to plug that number into the function g. And we'll get a number back, and that number is g of 6. We then take this new number, and we plug it into the function f, and at the very end will be our answer, f composed with g of 6. So, more specifically, we need to know what g of 6 is equal to. And to figure this out, you go to your function g, and you put a 6 in place of the x's. So 6 goes here and here. We have 6 minus 5, and that's 1. So what we just did is this very first step. We took x equals 6, we put it through the function g, and the number we got back was 1. So we now take this number 1 and we put it into the function f. So that's our second step. If I put 1 into the function f, I get 1 squared minus 3 times 1 plus 1. That's 1 minus 3 plus 1, the result is -3. So the very number here we have at the end is our answer. F composed with g of 6 is equal to -3. And the reason is, we first put 6 through g and got 1. We then put 1 through f and got -3. So let's try the same process here, similar example, but what we're going to do is just choose a different number for x. So how about x is equal to -1? So what is f of g of -1? We'll first put -1 in place of g. We'll then take that number and put it in place of f. So my starting point again here is x is equal to -1. I need to know what is g of -1. So g of -1 is, you put a -1 here, you get -1 minus 5, -6. All right, we now take this new value and run it through the function f. So what is f of -6? So the answer here would be -6 squared minus 3 times -6 plus 1. So that's 36 plus 18 plus 1. And the result at the end is 55. So being said, altogether, f of g of -1 is 55. And the reason was, we started with x equals -1, put it through the function g, got -6, took that number, put it through the function f, and got 55. So the last thing to consider here in example 1 is, what if we reverse the order of the functions? Like here, this was f composed with g. Is this the same thing as saying g composed with f? So what I'm going to do is figure out what this composition is equal to. So as a separate example. So I'm going to start with -1 again, but this time I'm first going to go through f and then go through g. And what we're solving for is g of f of negative 1. All right, so starting with f of negative 1, I'm now plugging that number into this function. That's negative 1 squared minus 3 times negative 1 plus 1, or 1 plus 3 plus 1. That's 5. I'm now going to take that number 5 and put it into the function g. And when I do, I put 5 in place of all the x's, I get 5 minus 5, and my result is 0. And at the very end, what all this work means is g composed with f of negative 1 is 0. The thing to point out is that these are not the same. And all that means for us is f composed with g and g composed with f will almost always give us different answers. There are cases where they could in fact be equal, but in general you can't assume that that is true. So again, the point of this example was to just understand what does a composition mean in terms of plugging numbers into it. So let's look at one more example of computing or evaluating a composition of two functions. So this time, instead of giving you f and g as actual functions in terms of x, here I have a table of values. One is for f and the other is for g. So like if you put 0 into the function f, you get negative 4. You put 1 into x, you get 8, and so on. And the same thing holds true for g. What I'd like to figure out using these tables is what is f of g of negative 2. So we'll start there. F of g of negative 2. At this point, I know exactly what this symbol means. It means we start with the function g and we put negative 2 into it. We get a number back. We then take that number and put it in place of f to get our final answer. So there should not be a lot of work that we're writing out, but I'll try to write the path for it. So I start with x equals negative 2, and I'm putting this into the function g. This means I have to look at the table for g. Here's negative 2 for x. I put it into the function g, and I get 1 back. So this is like step 1. X was equal to negative 2, and that number first goes to 1. I then take this number 1, and I put it into the function for f. And I see that 1 is sitting right here, and if I put 1 into the function for f, I get 8. So here's the path all together. We started with negative 2. It took us to 1. That number then goes over to this one and goes through the function f to give us 8 as our final result. So this is it. F of g of negative 2 is 8. Let's try this for the next one, which is g of f of 5. So again, I want to write the path down. Like, what do we get by using these two tables? So we're starting with x is equal to 5. Now the order here is backwards from this example. We're starting with x equals 5, and it's first going through f. So this means I first have to consider this function. So here's 5, and it first goes to 2. I then have to take that number 2 and run it through the function g. That means 2 is right here, and when I put it into the function g, I get 3 back. So just to put that together, I found x equals 5. It went to f of x equals 2. That 2 shows up here for the function g, and then goes to 3. 5 goes to 3, and that is my answer for this problem. I also wanted to look at a couple of other possibilities. Sometimes you can't actually compute the value of a composition if the numbers aren't there. So let's look at f of g of 5. So this is like the opposite of this. And then f of g of negative 1. So let's see what happens there. So this shouldn't work. What is f of g of 5? All right, so we're starting with x is equal to 5, and we're putting that through the function g. And we immediately have to stop. No good. There is no 5 that appears within this table. So this means we can't finish this process. 5 is not in the domain of this function. So there's actually no solution. There's not enough information to continue in this process. Now, what if we compare that to this, f of g of -1? Let's check that out. So f of g of -1, what is this equal to? We're starting with -1, and again, we're first going through the function for g. Oh, and this is good. Here's -1, and it goes to 9. So no problem yet. Now we have to take this value 9 and find it over here for f. And here's a problem. There's no value over here for which we can plug into the function f. 9 doesn't appear on the list. So the process actually, again, stops. There is no solution. There's just not enough information to move forward in this process. So one thing to point out is, if you try to find a composition, you have to make sure it's going to somehow work through this process for both functions.